All right. Thank you everyone for coming. This is going to be like the deep dive on Substrate and Parachains. My name is Alejandro. I'm an application engineer at Party Technologies, and well, without further ado, let's jump into what brings us here today. So I know that Rada has already like been speaking about Substrate, but I want to touch base again a little bit on that, and but I will go a little bit quicker because that content has already been covered. But anyway, so as you may know, like Substrate is an open source modular and extensible for building blockchains. What does this mean? This means that Substrate brings together like all the not tools, but yes, like it brings all tools, all the little pieces that help us build any blockchain, like any kind of blockchain. It's totally agnostic. It doesn't make any assumptions on how our chain looks like or how is it going to work, and uh, give us all the freedom to build whatever we want to. Okay, so you can like say it this way: like if you can code it, like you can build it. Substrate enables you to do that. What as it says there in the screen, it's open source, it's modular, it's extensible. Everyone can build um, any new feature for Substrate. Anyone can participate on the development of Substrate. So it's like pretty awesome in terms of what it like offers and enables to do from the point of view of the community and like all the chains and products that have been like created with it. So as I was mentioning, provides all the layers. Everything comes back into Substrate. Like it takes care of the database layer, networking, consensus, transaction queue, like everything that's listed out there, and much more things. It takes care of all. So if the developers want, they can like solely focused on developing like the business logic on the chain, right? This business logic, like one way of building them are through Frame. This is like the way of composing these modules, these different modules that will eventually like create runtime, the business logic, like how transactions are validated, how like storage, like how state is transition from one point to another. All these like logic is encapsulated into like different modules called pallets, and all these pallets are composed together like with Frame, right? So Frame is just one way of building runtimes. Um, Very well thought out way of building them, I will say, but not definitely the one or not the only one, right? So another thing that I would like to mention here is like all these layers that appear here, like the database consensus, like networking, like are implemented one way, for example, or have like some defaults. Uh, when you take Substrate as it is right now and you try to run like and even though like for example maybe they are using like RocksDB for your database layer, PartyDB or whatever, like as I said before, like it makes no assumptions, so you will be able like to use any database that you want, more or less. Like at least like there are like some layers of abstraction and key value like over the database, so like what is underneath effectively could be like whatever thing, right? And this is applicable for all the parts of Substrate. As it appears there on the slide, like each of which can be customized and extended. Right? 100%, like this is applicable for all. And this what we have here. It's like how does a node looks like from like how is the architecture of a node or a Substrate node? What do we have running? What pieces are moving, right? As you can see in there, like the main hub, like the center of this infographic, like what brings like what catches our attention the most is like the WebAssembly runtime. This is the business logic. This is the, as I was mentioning before, what defines how we transition from one state to another, how like transactions are checked if valid or not, and so on. And then like communicating with this runtime, like we have other parts on the client, like clients, RPCs, browser extensions. We can have like all the client side of the node, like underneath there, in that rectangle here. We can have like the networking discovery, like the consensus storage, like this will be like the DB layer, TX pool, WebSocket for connections, like everything else. And with all this packet, like there will be another nodes talking to each other. So more or less, like this is just like a quick scheme for having in our heads, like when we're thinking about a node, a substrate node, like which pieces do we have in there, right? So the next time, like being the main focus of the runtime, like it's what we have in the runtime, like what is a runtime. So I have repeated like already like a few times, like that the runtime enables the state transitions, like it tells like the whole system, like how basically to jump from one state to another. Um, and Substrate, like at least with Frame, like the way we do this is like by composing different modules, different grades called pallets. I already mentioned that too. That each of them like is specific and focused on one thing, one part of the logic of our whole system, right? And this could be like, for example, we can have a palette for choosing the next set of active validators, or a palette for having identities on chain, a palette for minting assets or minting NFTs. So it's like we can add or take out like features as we want, like by using these palettes, installing or like uninstalling these palettes, right? Well, let me go back because here I didn't mention like last sentence in there, like runtime is built on blob that is part of the consensus. So what does this mean? Like this wasn't blob is part of the consensus, that meaning like it could be upgraded if such is decided by consensus. So now yes, let's jump to the next slide. If we want this code, this wasm blob that is sitting down in our storage, part of our consensus on our chain, can be updated. So we like define new rules as we want, as we need, as maybe as our requirements grow or change over time. We can adapt our chain to those requirements, or maybe like our community is lacking some feature, and we can add that like as we want, like basically with a runtime upgrade, that it's just a transaction that upgrades all the network at the same time with the new logic. So that is pretty awesome. Upgrade, like if this feature, like if runtime upgrades are not there, like the other option is like forking the network, right? So and forking the network like requires a lot of human coordination, like not only like on-chain effort, but also like coordinating all the node operators that are running nodes to upgrade to the new client if they want. And this like solves a little bit that, right? Like there is no need of coordinating people, humans. There's just one transaction that sets the whole network, like working with the new updates, with the new features, with the new security fixes right away. And that's really cool, really cool. And I think it's something like it's very, very welcome and very appealing, like when you're working with Substrate, right? So, well, as I mentioned there, like you can change core rules, you can add new features, fix simple or like vulnerabilities, and so on. Okay, so that was Substrate, and with Substrate, like mostly when you are developing like your change or logic, you will be developing pallets, right? So how does it look like? So This what we have in here is more or less what like a skeleton, bare skeleton of any palette looks like, right? We will have like a palette struct where we will be like implementing like the rest of the components of this palette, right? And we will have a trait. This will be like exposing all the types of the traits that we need to implement when we want to install this palette in our runtime, right? So maybe we can declare here, okay, our palette is going to use events. It's going to use this configuration type that it's going to be declared at runtime, at the implementation of the runtime, right? So we will have the config. We will have a series of storage items, right? This is the storage items that are going to sit on chain and are going to be part of the consensus. We can declare events that our palette is going to throw away for users to listen, to track, for other applications to follow, and to inform what is happening like on chain, right? We can also have hooks. Hooks, as its name I think very clearly shows, are actions that need to be taken when an event happens on chain, right? Like for example, a random upgrade happens, so we're going to trigger this set of logic, or I don't know, like a block is being initialized. So at the beginning of every block, we want to run this piece of logic at the finalization of a block, things like that. And then we will have obviously calls, extrinsics, as we call them, that these are transactions that anyone can sign, or anything can sign and send to interact with this palette, and this will trigger like some logic that is defined. So our external are calls that can be like made from the exterior of your chain, right? Like external calls basically need to be signed. Note that it's up to you when you're developing your palette. You decide like these things, but you can see that they're notated with this notation here. Palette call, that's what like shows or like indicates like, okay, this can be like available for external calls, and you will have to sign, and usually you will have to pay some fees for this and such. So all these annotations that are like on top of every different element within a palette are basically macros. These macros are code that will like expand into more code, but like abstracts out of complexity from our side, from the developer side. So when you are like coding a code, I don't know, you are declaring a storage item, something like that, you can just type that and forget about the rest, right? Like Frame will take care of extending this and included it in your runtime, like with the code, with the needed code for this. Macros are very heavily used all across Substrate, with the main purpose of like um, what delivering better code, but also like improving the UX of the developers. So it is pretty awesome because, for example, like I don't know, like maybe like you have a macro in there that is just like extending like a lot of enums and including what you have written in a lot of enums, and you don't want to do that like every time. So it's very handy. And when it comes to designing your runtime, here's when you have to take the decisions. You have to be like smart. You have to show how smart you are, and you have to start making decisions like, okay, which items are we storing on chain, which don't. As you know, storage on chain is like something that you should be paying for. Resources are not infinite, are limited. So like every use of our limited resource like should be like made under certain circumstances, and eventually like you will end up paying for them if you want to run some computation. if you're doing computation, if you are like taking a space of the whole storage of the system, you will be like paying for those, right? So the simpler the data structures we use, the best, because that will lead to um, more efficient state changes and maybe more efficient logic to manage those. So that is something to have in mind at least. I just wanted to mention them. Nothing, nothing, nothing that. Well, it's just something that it's good to mention, right? Okay, so when it comes to declaring storage, there are different types that we of doing such, or different items that we could use, from the storing a very primitive, like here, for example, U32. Just want to declare that we just want to store that on chain. So this will be like the syntax for doing such. We want to store its value, U32, and the value created. This is when we are. This is important for when we are querying this information. Not something that we should really take care of right now. We could declare like this very same item could be made public if we want so. I forgot to mention that here the very first one is private. The item, basically this comes from Rust, but not declaring it that is explicitly not declaring that is public. Then we're making it private. So if we want to make it public, we have to explicitly tell that with this pub instruction there, not instruction, but keyword. We can also declare like default getters for our item. In this case, so we're declaring that this function, some primitive value, will be like the way we obtain like this U32 that we have defined here. The other way of doing this will be like calling some primitive value, like okay, like .get, or like using the functions implemented for this type. And then, like we can like very quickly refer to that function as a getter, right? There is no need of only like storing values. Like we can, store custom values or predefined other structs, or like account ID. Account ID will be like different from chain to chain, from runtime to runtime. So there is nothing special to do with that. When we are storing on chain, we just need to refer the type that we are defining. Like there, I don't want to try to explain this in a way that it could look like more complicated than it is, because it is not. Like there will be like just a definition of our custom type elsewhere, and we are just referencing that here. Okay. Put it up there. Perfect. So we were storing value there, yes, but there is also like maps. Like so, for declaring a map, we have to well, obviously like declare a key, the type of the key, the type of the value that we are storing, and also we have the opportunity to declare the hazard that we are going to use for this key value relation, right? In this case, our sum map, that's the name of our map, is a storage map. That's the keyword for declaring this like single map. And we're telling like, okay, our key is account ID, our value is going to be like a U32. The hazard for this whole relation is going to be like that hazard, that type of hazard, like 228 concat. All right. So more or less, like it's the syntax is very consistent across all all the storage items. And likewise, like the same way, we have maps, we have double maps. So for the double map, maybe you can imagine, we declare that we are instantiating a storage double map. First hazard for the first key is going to be like Blake2. We have first key U32, second hazard for the second key, another Blake2, 128 concat. Second key is going to be account ID, and finally our value is going to be of type U32. There is also, I didn't write them here in this slide, but there is also like nmap relation. So you can basically declare like more than 2 keys if you want to do that, right? Let's continue. Declaring events. So the same way that we can declare storage items, we can declare events. These events are part of an enum. We will have like a list of events right in there in our palette. And in this case, for example, we are declaring an event that it's called value set. And inside of this event, like we are saying, okay, we are going to emit, we're going to show with this event a value that is going to be like a U32 and an account ID. So we're showing 2 things along with this event, right? And here, for example, here's like in our config of our palette, like if we are using events, we will have to say, okay, hey, our events are going to be using like these traits. For example, events coming from the frame system, that this is like the very base of every palette, and the event definition, right? There's like the event traits. But even though like as we are trying to use events, we have to declare that on the config of our palette. So later on during a call, we will see it later, like these events will be deposited as a means of informing users or applications listening to what is happening on chain that this has happened, and these were the values. For example, in this case, these were the values set by this user, this account. So and this is how it will look like declaring an extrinsic, a call, a dispatchable function. Those names are, you can like use them for to refer these externally call these calls that can be like called from outside of the chain, right? In this case, we have the annotation pallet call that implements our struct palette that we defined previously, and inside of this implementation, we will have all the functions that we will be able to sign and send to the chain, right? Usually, like always, you will see these annotations on top of each of the calls. This relates, or this is telling us like the weight of doing this execution. The weights are the way we measure how much our computation costs, because afterwards these weights will be translated into fees that someone will be paying. So to obtain these weights, basically what you want to do is benchmark your palettes. Once you have written them, these benchmarks, this is a functionality that Substrate has from the very base. Like you can like benchmark whatever you're writing with Substrate, whatever palette you're writing, will give you like some values, right? You want to keep these values in order to have consistent execution environment. I don't think that's a correct way of like putting this, but what I want to mean is like per block, you want to allow a certain amount of execution, right? And that amount is calculated by these weights. So every block will have a maximum weight limit. Like we can include more than X amount of weight, and each extrinsic, each function will have its own value here. So That's how you will like calculate how many computation fits into a block. Okay, let's go to look a little bit more here. This function, for example, it's this function taken from the template palette. Basically, it's called do something, so it does something. It receives an origin because this is a function that is being called from outside the chain. So someone um, has to be like the responsible of this call, right? So the origin is like this where this is coming from, like this signature maybe. And then like we have like some parameters here that the function receives, but this patch result that this is what our function will be like returning, right? So our very first line is like this who, like definition, like who is who. We are taking like answer signed. What we are doing here is, okay, let's see if this extrinsic call that we are receiving, it's signed. So if you know who is signed, if you know if it's signed or not, like you keep the signatory, the account that is signing. If not, like basically here you will like drop the execution. Like, okay, like we are requiring it to be signed and it is not, so we stop. The next thing this function does is like updating the storage. There is in this palette one storage item called something, and here like we are just putting something that is the U32 element we are receiving as a parameter into this storage item. And after we have like finished everything that we had to do, like we can like deposit an event. Something stored in this case with something cool. So we are like letting everyone know like, okay, this has been modified, like this is the new value, this is the signatory, like this is like the account that has triggered this change, and we return a successful dispatch result, right? So these three like words that I have here, validate, update, communicate, are like the basic, very basic like mantra that you have to have in your mind when you're developing a palette or an extrinsic. Like first of all, you need to validate. If you need to stop the execution, if you need to stop everything, like the earlier you do that, the best, because you are saving time of execution that way. Then to update everything that you have to update, and at the very end, like to let everyone know what has happened, right? That would be like very like a healthy flow of when developing like this extrinsic. For hooks, we have like this collection of hooks, maybe more, um, maybe less. Well, at least these are the ones that come with frame, like from the very base. Like as I said, like everyone is free to develop more, to extend everything. So usually, like you will find these ones, right? And as I said, like they just like trigger some execution that is defining your palette when an event happens. It's an API for things that happen on the chain. Not much to mention here without like entering out of detail. So let's jump into building a runtime. Like these are like some details, some colors on the, how like how do I develop a palette, and how I take my custom palette like this, like firstly develop palette into my runtime. So what you want to do is inside your runtime, you will want to implement your palette. Then how does this look is like in this slide, I've taken the implementation for the palette mix for runtime. It's a fairly simple palette. Interesting to check out. It enables like an account to display a nick instead of the account, like, or at least relate an account with a nick. If someone wants to show it, like it's up to them. Anyway, so what are we implementing here? What are we implementing for pallet nicks in our runtime? Why do we have this list of elements and not other ones? So this list of types that we are implemented here are the same ones that we will find in our config inside of the pallet. When we are defining our pallet, we will be defining a config. And those are the types that we will have to implement when we want to include that in our runtime. So in our case, like for example, here pallet nicks, it's implementing the currency trade. Currency trade, it's like everything that it has to do with token management, like with currency management. Like so, I hope like that makes sense. In this case, what we are like looking at there is like what this palette is saying to us is like, okay, like the implementation of this currency trade is being taken care of by balances palette. This balances palette will be like the same way than this, implemented in this runtime, and this is what we call like loosely coupling palettes. Basically, we are exposing a trade, and the implementation of this trade happens in another palette, and we will be using the functions defined in this other palette, right? For example, reservation fee here within the Nix palette is basically a constant. We can define like constants at the implementation time here in the runtime. Usually, if you check runtimes that are being implemented, instead of having this value right away, like here you will have like some definition of on top of a constant or something like that with a fancier name that constants will be equal in this case to this 100 value, right? We can do things like not implementing or no action. For example, here slash no actions is taken when the deposit are forfeit. We can like implement nulls. Like we can have no behaviors for some things, right? And origins are important and usually like, and they are always like defined at runtime level. Origins are what we use to, I don't want to say filter, but I guess like it's a fair like it's fair to show what we do to filter like um which accounts or which signatories can do what. Maybe we want, for example, like in this example, like you see like force origin there is and so root in the substrate frame context means like the system. So you can like the narrative of understanding this will be like the system has decided that this has to be executed instead of myself signing a call want to execute X function, right? So I will be like, you can understand that like Alejandro has decided to or it's requesting execution for X logic. Root in frame is like the system itself. So it has like the more privileged origin type of access because like why not? Why will the system wants to do something harmful for itself, right? So you want to put like this filter, this barrier. You want to ensure is under root or under other custom defined origin. In some extrinsics, maybe like where you don't want anyone to be able to call that. I don't know. Maybe you're forcing a state change, and you only want root to be able to do that, right? And that's it. So implementation of the config in the runtime. That's I just walk through it a little bit, but you will have to implement the config that you defined in your palette in your runtime. And after that is made, within the construct runtime, this macro construct runtime will have all the palettes that compose the runtime. So we will have to include our palette in the list. It's basically a big menu. So we can say like, hey, I want my palette to be part of this runtime. And when you build the runtime, if your palette is there and everything is correctly configured, the and you run your chain, you will have the features you have included with your Pallet, right? So that is how runtimes are built. Basically, like the long part or like the more complex part is like defining, developing all the logic within a Pallet, and after like including that into a runtime is more or less like fast because you just have to implement um, the config for your Pallet. Maybe that takes a little bit more time, or it's more delicate because you're doing a 13 implementation precisely for 13 runtime, so you have to take care when doing that. But 2 steps, um, and you have your Pallet installed and running in your runtime. So parachains are different from a standalone chain or like a regular chain that we have developed previously. Well, first of all, to develop parachains, we use Cumulus SDK. Cumulus SDK is a series of tools, APIs, code that makes your network, your chain, this parachain that you're building, able to communicate with a relay chain, right? So the main benefits of, well, let me stop here for a minute. Like, why would one want to develop a parachain? Like, first of all, there are like so many benefits, right? You just got like certain security benefits from the relay chain. Like all the finalization comes from the relay chain. So you, as a parachain team, you don't have to take care of bootstrapping a secure and decentralized validator network to do that for you because you already have it there. And why do it again? And maybe you don't even like get that many validators or that many decentralization. So let's um, scale by specializing heterogeneous shards, and let's keep like the decentralization in this like shared platform. Like for example, it are Polkadot or Kusama, where every parachain can go there, like connect after acquiring a slot and start, like for this security. And on top of that, you get things like intercommunication and such, right, between other parachains that are connected. But yeah, the Cumulus SDK is basically like a set of code, a set of tools from where you want to start building your parachain. It will take care of like synchronization with the relay chain, like all the communication between the two sides, parachain, relay chain, and such. But as I was mentioning, like web parachains, like um, obviously, as mentioned in there, like they are way more optimized for the specific use case they are tackling than if you create a general purpose chain, right? So this will translate into maybe like way less fees or uh, more like more capacity of computation for because the code is like better tweak, more optimized, like it's doing like some um specific optimizations for these, because like for such a use case, because it doesn't have to take care of X more. Anyway, the second line in there, like set your own rules and limits, is a very nice point when you're comparing like why parachains and not smart contracts. Like why will one choose a parachain before a smart contract? That is because when you're building smart contracts, for example, an EVM, the rules of the EVM are already set there. Like the walls to which you can push are already set. Your smart contracts have certain limits that are defined by the EVM. If you're defining your parachain, you set the walls, you set the limits, you set the rules. Maybe you want your chain to accept a huge amount of computation per block. Like maybe it makes no sense, but you can do that. Or maybe, I don't know, like you don't want to charge fees to anyone. Totally possible. Makes sense. Does the business work after that? I don't know, but the opportunity is there. So That is that weighs a lot when choosing this, because well, you're playing with your own rules, you're coding with you're setting the limits basically. So that's pretty nice, pretty neat. Interconnected with the rest of the ecosystem, we will talk about more about that later. And as I was mentioning, like, there is no need of bootstrapping like a decentralized set of validators. I think this is a huge win for Parachains. Like, decentralizing, like truly decentralizing a solution is very complicated, and getting like this network of validators that basically are people that want to run your node, want to maintain your network, is not as straightforward as it may seem. So yeah, at the end of the day, like, teams can focus on building like their solution, their logic, their business logic, instead of taking care of way more things that they should, right? Of course, like, as it is, all these like intercommunications and all these like synchronizations between like parachains and really chains, everything is made in the trustless ways possible. So start of parachains, we include a few new concepts, like for example these collators. What are collators? Collators are the authorities on the side of the parachain, so basically they are the ones producing blocks on parachains, right? And understand authorities as the nodes that have that job, right? Nothing else. They will be like validators on the relay chain side, right? So they will collect all the transactions, everything that is happening on the parachain. They will build this block that we call the proof of validity. They will send that. They will communicate that to the validators on the relay chain side. That's what they take care of. And of course, like, very important, collation, like these collators doesn't perform any security activity. They don't secure the network from the relay chain. The security of the network comes from the finalization that is happening on the relay chain. They just care about like availability of the network and producing blocks, basically. So they to be sized, that's up to the team, of course. Like, the more collators that you have, more available your network is. So why not? It sounds reasonable, but you don't need like to incentivize them, because if not, your network is going to be insecure. So you need people running your nodes. That is not the case. Then okay, like, if you can run your nodes and everything, like, how do you jump? How do you become a parachain? Like, how do you get that status? The answer here is like the different relay chains will manage this in different ways. I can only speak like for what I know, that there is Polkadot and Kusama relay chains, right? So they use slot auctions, and I have the two candles in there because they use like candle auctions, what are called. That is a way of implementing an auction, like a way of making an auction, and to avoid that someone with very big bags arrives in the very last moment, checks the last bid, and say like, "Hey, I have more money, I want to win." That does not take like that. We have a little bit of randomness into the equation, and it's healthier. I think the auctions like this way are healthier, right? So these slots are being auctioned when when one bidder obtains a slot, wins, then it can onboard the parathread, becomes a parachain, start producing blocks, start getting like finalization and everything, and it will sit there like until the slot is gone, basically. That for example, if you can see there in the picture, this is Kusama, like some days before this presentation. There are like almost 40 parachains. On the right, you can see like the amount of days that they will be like onboarded for, right? So that is the amount of time they will be like holding that slot until they have to renew it or to go for an auction again, or different ways, right? And it is very important. Maybe the slide doesn't show it like perfectly, but when you are running a parachain, like one of the things you have to take care of is like, okay, I want to build my chain spec. I'm running a parachain, and that hopefully like more people will join to run nodes too. So you need to have your chain spec. You need to share your chain spec with your community. Um, Usually this is the way like we build the chain spec. The two first lines. You will build first the plain chain spec. This comes from basically the code that you have implemented in the binary that you are compiling. And after having the plain chain spec, you will build the raw chain spec. You will be able to share that and run your nodes with that. And that is like what represents your chain and can like select your chain from all the different chains that are running, and the node will be like, okay, I know how to identify the other nodes that are running the same thing than I do, so I can talk with them, I can connect with them. Also very important from this chain spec is from where you generate the Genesis code, the Genesis WASM, and the Genesis head, that is like the Genesis state for your chain. These will be the ones that you will be registering on the relay chain before being onboarded, before being a parachain. You will, you will have to register them and say like, hey, this is the code, this is the state that I'm going to run from, right? After they're like, obviously, like parachains are very welcome to do runtime upgrades and everything, and it's very flawless and works very well. But there is like a baseline. There is like, like they have to start from somewhere. These are the ones. Okay, so we have parachains onboarded, and as I have mentioned before, like there is interoperability. These parachains can communicate between them. What is this? How does this work, right? So XCMP, you will have heard about this. One very quick note I want to mention before going deeper is XCM is not the same as XCMP. XCM is a format. It's a language. It's the way we write the messages in these messages, right? How does this data looks like? That is the format. That is XCM, cross consensus message format. XCMP is just a message passing protocol. XCMP just takes care of like some bytes go from point A to point B. That's it. No more, no less. That's it. There's a lot of confusion. There's a lot of people like that use these terms like if they were interchangeable, they are not. They refer to different things. And I wanted to be clear on that. Okay. So mostly I will be talking about the XCM, about the format here, and not about the message protocol. So who talks to whom? Like who can talk with whom when they are interconnected, right? All parachains and parathreads that are connected to each other, parathreads not implemented in the moment of this talk, right? Can send XCM messages, so messages that are written with XCM, are with that message format, can send between them as much XCM messages as they want from the very base. Like that's granted. As soon as you are onboarded, you can start sending XCM messages. Trustless way. Perfect. Nice. What happens with other chains that are not parachains or are not parathreads? What will happen? Okay, so you will be able, of course, to send XCM messages because this is just a way of writing messages. But instead of like doing that through the relay chain or through like a peer-to-peer XCMP protocol that connects and sends bytes from one parachain to another, you will be using a bridge. For example, this bridge will be connected to a relay chain, and anyone that is on the other side of the bridge will be able to send messages, okay, with the rest of the ecosystem. So no problems with that. Here, the protocol for sending messages is, instead of XCMP, would be the bridge. But the messages that will be like flowing, that will be like being sent within this bridge, can be written in XCM, right? And as I mentioned, like there at the end, like even though like you are not a parachain, even though maybe you are a solo chain running alone in there or whatever, or you are Ethereum or you are, XCM is available for you to write systems or messages and to communicate. And it's very useful when you want to reference other consensus systems that are not the one that you are, right? So it's just a format. Is It's not a standard, but it will be cool. But it's just a format that is available to everyone, to any system, to write messages in. Okay. So um, what features or what is happening now with these XCM messages on this substrate like Polkadot world? So we have asset teleportations between chains, we have reserve transfers, we have arbitrary sends of XCM messages, transacts. This can translate to asking for some execution in another chain, like, hey, like, can you execute that function for me, or I'm sending you these tokens, and you like do something with these tokens and send them back to me, you know, things like that. Or just like, hey, I'm going to create some tokens in that chain for me, and I'm going to destroy them here in this side. But the good thing about like what happens within the Polkadot ecosystem, for example, or Kusama ecosystem, is that it's trustless. So you don't have to depend on, um, like some smart contract on one side of the bridge or something. Well, with the exception of teleportation is one condition reserved for trusted systems, because basically what it does is like burns an amount of tokens on one side and creates the same amount of tokens on the other side. So that would be like the exception of the rule, right? But moreover, all these communications are asynchronous. So it doesn't block you like waiting there until you get your response back. And well, how is XCM being elaborated? Like what use cases are being built with XCM? So different chains are adding support for different assets of other chains in the ecosystem, as if they were like, like their native asset. They can reference the assets. They can like do operations with those assets. Maybe like that's a token that is sitting down in another chain, right? As it says, they're using external assets. Governance delegation, that's, for example, it's very cool, very easy to see. On common good parachains rely on relay chain governance. So they basically like execute like all governance stuff through XCM. And for example, like runtime upgrades on state mine, that will happen like through that will be an XCM message telling the chain, hey, you have to upgrade your runtime, right? And the decision making, like the governance process, will have happened in another chain that is not the one, the state mine in this case. Okay, this year, because XCM like it's a beast in itself, right? There is like the virtual machine that is executing all these messages, so there is like a lot of configuration behind it. And this, for example, is like the configuration of the XCM executor. This will be like the one in charge of executing the messages received. And you can see here there is like a really big config with a lot of different, where we can like configure like the assets transaction, the origin converters, like origin converters, for example, like how we interpret like an XCM origin, for example, an XCM origin that is referring to another chain, like how do we translate that so we can, like, like execute and make someone pay for this execution and keep everything like healthy, like that everything is making sense, like this is not a fictional origin, like this is actually someone, right? And we can configure like if some chain is a reserve for another chain, so the assets can be reserved and transferred from there. Teleportation of tokens, in location inverter. This has to do like with how these origins are understood and everything. There's help us with the definition basically of who can and who cannot like execute things, like which origins can and cannot execute things in our chain. Wager, the wager, it's the piece of the XCM executor that takes care of of all these weights for the XCM itself. Trader, that I have like snipped all the content in Trader because it was huge, and it's the one like translating the weights to the actual fees that have to be paid off, and who pays this, and like where is this paid from which accounts, because you are like referencing and doing like executions and transfers from one consensus system to another one, and maybe like it's not trivial. It enables really cool stuff. It's not trivial though, and such you can see here. And the same way, like with this XCM executor, like the main purpose of me like bringing this huge config here was like with the XCM config, the whole XCM config for, in this case, state mine, and we can see that the XCM executor is just one part of this whole config. So even though these kind of configurations right now are all of them like very similar to each other, so you can like take, for example, this one of state mine as a baseline, and from there like do your little changes in that. XCM, like the VM, like it's a really beast. It's a beast, and it makes a lot of parameters for the configuration. It takes there are a lot of things happening in there. Of course, it's not something impossible to master or to learn, but it's not the easiest thing. But when you see it finally working, and then you are like sending transfers with another chain, and for example, you are making a request for some execution, you are upgrading another chain that is not the one we're executing things. It's really cool. It's very amazing. So that's it. I didn't want to get into much details with it. I think we will be here. I don't know, like I'm not like a professional with XAM neither, but I think we will be here like at least 2 hours if we start like talking of each of the we could talk about. So that will be it about XCM, and that will be it about like the presentation. So I had like some time for questions, but I don't know if we will have questions. So thank you very much. Be it from my side. I hope it was useful. I hope like at least like gives you like interest to dive even more and start like developing.
Alejandro, that was awesome. I really appreciate it, and I know a ton of people are going to be I'm sure pinging the Discord asking for some support after they go through this, but I really appreciate it, man. And definitely wait a second. I don't know if God's Power Imophodon has any questions. If you do, go ahead and put them in the chat. If not, then we'll make sure to answer any after the video is reviewed. And again, Alejandro, really appreciate it, man.
No, thank you for having me.
Absolutely. Well, I hope everybody enjoys the rest of the evening, rest of the day, depending on where all of our participants are. But again, Alejandro, Sophie, really appreciate it. I'll make sure to send the recording over to you, and then we'll either post it in Discord or wait for you all to give us the green light to post it in there.